My name is Richard Barker. The title of my book is Sharing the Excitement of Growing Plants in Space. So the summary of the book is essentially me just describing some of the things I've encountered since working with NASA to grow plants on the International Space Station, and some of the ways I use this to get students excited about plants in general on Earth. So all good stories start once upon a time in a land far, far away, across the sea. A hero was born. No, I was born in England, and I started off to tell you my backstory. I started off studying plants and the environment. I wanted to be an eco warrior, so to speak. So a lot of people ask, like, how can you go from being an environmentalist to advocating the journey to Mars and trying to grow plants on the moon and in other extraterrestrial environments? It's quite a contrast. And so in order to see how I came to that perspective, you kind of have to start at the beginning. So I started in the UK at the world's oldest agricultural research institute, a place called Rothamsted Research. It's this beautiful old 16th century mansion where they've been growing plants for a long, long time. And I studied something known as the Green Revolution. So the Green Revolution is the intensification, mechanization and industrialization of modern agriculture that occurred essentially since the 50s. And we've all seen those graphs of the human population kind of going exponential. And food productivity did the same, fortunately. So we continue to enjoy the benefits of cheap bread and milk and the like. And so I started researching how that took place. So there's the economic side of the story and like the industrial side of the story, and those things are kind of out of control, like the politics and that. But the genetics side of the story had never really been written, and so I worked with some really great researchers to try and uncover some of the genetic mechanisms that are led to these really high-yielding crops. The technology I used was genetic engineering to shed light into this, and essentially created a toolkit that allow researchers or people with other motives to essentially make any part of the plant larger or smaller. You create the stem, the leaves, the roots, the fruit, any part of the plant about 20% bigger or smaller, depending on how you do it. And then in the early noughties, just after 2000, there was a lot of negativity associated with genetic engineering, the biotech companies, and so I didn't really want to be just working for some big sort of soulless conglomerate, multinational corporation. And so I wanted to go back to something which was more academic, something, a fundamental mystery that had never really been solved. And so Darwin came to the rescue. So a couple of hundred years, just over 100 years ago, Darwin, back in the UK, realized that plants could sense gravity. He turned some plants on their sides, and the shoots bent up and the roots bent down. Many people said, well, the shoot's going up towards light and the roots are going down towards water. And then he removed those two factors, and the plant still knew what way was up and which way was down. Darwin went one further. After basically demonstrating that plants were able to perceive their orientation relative to the vector of gravity, he then realized if you cut off the root tip, the root wouldn't bend down. And he went on to say that the root tip had some kind of gravity sensing mechanism that was allowing the plant to adapt. A century or so passes, and the story hasn't got much further than that. And so after completing my PhD, I was lucky enough to get the opportunity to come here to work at the UW Biotech Center in Madison, where I worked with one of the professors who was trying to unravel these genetic networks that allow plants to perceive gravity. And that was a lot of fun. It was really nice. And I fell in love, and I went back to my hometown with my then girlfriend, who I then proposed to. And this was the turmoil, because we then got engaged, we came back to America, but I made a mistake on my paperwork. The visa and immigration laws here are really strict, really tight. And so I lost my job and essentially got kicked out of the country, separated from my fiance. I was back in the UK, stranded and jobless, desperate to get back here to the new world, to the land of the free, to try and continue my kind of search for knowledge, search for information about how plants grow. Fortunately, there was this opportunity with NASA. Not many people have experience with designing spaceflight experiments, and not many people really care about how plants perceive gravity. And I had both those factors. So I was lucky that no one in the US actually had those skill sets, because of the US immigration law, all the jobs have to be offered to American citizens first. So after many months of searching in the US, no one was found, so the job was offered for me. So I got to come back again, and I got married, and I like to think live happily ever after. But the story doesn't end there, because that was just the beginning of this latest adventure with NASA. So that was how I became aware that I was about to get the opportunity to send plants into orbit. So just after returning, we sent some plants to the International Space Station, and as a plant scientist, this was really exciting. Usually I just sow seeds on a petri dish, and then I set up a camera and I do time-lapse photography of them growing, and I love that, and I could talk about that for days and days. But most students, they lose interest pretty quick, and particularly when you start to incorporate all the genetics. So it's really cool then to be able to start talking about the rockets, because that gets their attention back again. So I'm kind of shameless in the way that I use the excitement of spaceflight to make people think about plants again. So when we did the experiments with NASA, after sowing the seeds on the petri dishes, they then get handed over to NASA representatives at the Kennedy Space Center. They then loaded the petri dishes into the SpaceX Dragon capsule, which then got loaded on top of the Falcon 9 rocket, which then launched the plants into orbit. The Dragon capsule then docked with the International Space Station. The Falcon rocket then landed on the barge and came back to Earth. And our plants grew on orbit for about 8 days. After that point, our favourite astronaut, Reed Wiseman, he then injected a chemical called RNA laser. It's basically a concentrated solution of ammonium sulfate, which is irrelevant. What it does is it causes the proteins to precipitate out of solution and stop functioning. So the enzymes that would normally degrade the nucleic acids, the DNA, the RNA, they got broken, they stopped functioning. And so we were able to preserve the DNA and then bring that back to Earth. After examining the DNA, we looked for different genetic patterns to try and work out how the plants were adapting to this altered environment of spaceflight. So the microgravity is one component, and the cosmic rays are another component that are quite prominent when on orbit on the International Space Station. So looking at the plants' genetics, we realized they were drowning. And we have a paper coming out on that later this year. So that's kind of like cutting edge conclusion. But when you draw a conclusion based on data and science, as a scientist, you always have that intrinsic doubt. We're not like politicians. We don't have that fake confidence. We have to remain skeptical of ourselves. So when we started concluding that the plants were drowning, we were still looking for more confirmation of that, more affirmation of that. And this is when Scott Kelly kind of came to our rescue. So if you're not familiar, Scott Kelly is an astronaut who's the first astronaut to spend almost a year in space. He's a bit of a hero, actually. And so he was going up to the space station. He's actually one of the first space farmers, if not the first space farmer. He was able to grow some lettuce on orbit and then eat that lettuce. And that's something that's never happened before. So for the first time in human history, we have space farmers walking amongst us. The lady responsible for that, Joya, is an awesome, really cuddly lady, and she actually got to go meet Michelle Obama at the White House, and she was really excited by being awarded that kind of honor for her work. So after growing the lettuce, they needed another crop to grow on the space station, and because Scott Kelly was spending a whole year away from his family, from his wife and his kids, Joya thought it would be really lovely if he was able to grow a bouquet of flowers for her to be harvested on Valentine's Day. And so Scott leapt at the opportunity. He was really excited by this and sowed the seeds and put them in the veggie growth system on the space station. But just before Christmas, there was a problem, and he phoned down to Earth with that really famous line, "Houston, we have a problem." He actually said it, yeah. And this then gives you an insight into NASA bureaucracy. So he phones Houston then phoned the Kennedy Space Center in Florida, who then phoned the person who's in charge, Joya, who then gets woken up around midnight and gets forced to go into lab with this phone call saying, "Hey, the space station's calling you. And if the space station calls you, you go to answer." And it's basically Scott Kelly there going, "The plants don't look happy. They look really unhealthy. They're twisting, they're stretching. It looks like there's fungus growing on them." And these are all the types of symptoms that we would predict from based on plants that are drowning. So they had these epinastic phenotypes, is what the scientist was describing, which basically is just a scientific way of saying the plants looked like they were drowning. So Joya gave him some protocols. She told him what to do to clean the plants, adapt the fans, try and make the plants more happy. And a day later, there was another phone call, and Scott Kelly was phoning back down to earth again and was saying, hey, I don't know what you say, but the plants still look a bit unhealthy. Can we break with protocol? Usually I have to keep asking for permission to do stuff, but if we keep having these long delays as I ask for permission to adapt the environment for these plants, I think they're all going to die. And so at this point, Joya was ecstatic. She was over the moon, because as a researcher, you can't ask for extra astronaut time. It's at a premium. From the moment they wake up to the moment they go to sleep, every half hour they've got something like written down from a chore that they have to do for some scientist or some engineer on Earth to make sure that the space station doesn't fall out of the sky. So for Joya to have Scott Kelly say that he was willing and able to provide his own free time and any spare time in between to nurture these plants was a big deal, because she can never ask for that. One of the things I also like to point out is I think it highlights that the plants actually do really provide psychological support for the astronauts that are up there. So they're like 250 miles up in the air away from Earth in a metal box. It's the most alien environment that humans can really live in. It's really, really different from being on ground. And so we kind of take for granted that when we're stressed out, we can look out the window, we can see some plants growing there. They just don't have that. And so this kind of takes me back to the first conference, the first American Society for Gravitational Space Research conference that I went to. And I saw this researcher from Roscosmos, because like space science is truly international. It's one of these great places where all the different countries really do work together, apart from China being excluded from the International Space Station, but that's just an issue of Congress, which I probably should get into. And so when I saw this Russian scientist presenting their research on how important the psychology of the astronaut is, I was kind of surprised. I always thought the only justification for growing plants in orbit would be for food on a long distance journey to Mars or on a moon base. But suddenly we had the Russian Space Agency telling us about the cosmonauts that they put in isolation in Siberia that went crazy until they were given some plants to nurture. So we can really see that when people look after plants, it helps them stay sane. And I think that's not just true in space, I think that's also true on Earth. And so I think that's one of the great things we learn from doing space science is the things we learn up there really do help us affect life on Earth. And so I do encourage all of the people I work with and the people I meet to sow a seed in the spring and to watch that plant grow throughout the year. So when I was first encountering like the NASA organization, I started hearing about they all wanted to go to Mars. And to begin with, I thought it was a bit crazy. Like, why would anyone want to go to Mars? Earth is really, really nice. We should really preserve the planet that we have here. But there is one really fundamental concept that I really find it hard to disagree with, even as a cynic and an environmentalist. And that is the search for the answer to the question is, are we alone? So we know that Mars had everything needed for life. It was in the Goldilocks zone of the solar system many years ago. It had water, had the right temperature, had all the organic building blocks needed for life before Earth did. And so if life is just like a mathematical certainty, if you have the right conditions, then it should have probably occurred on Mars. And the rovers that we send over, like the Curiosity rover, it's just not the same as having a human searching. It moves so slow, it takes so long, it's never going to be able to really answer that question definitively. But having boots on the ground, that could provide that answer, like, did life independently evolve on Mars or not? So I think that's really kind of exciting. But how would they get there? Like, you can't really take everything needed with you. And so if you want to know more about that, the Mars Direct book is really quite interesting. It tells you about how they plan to make the rocket fuel for the return journey on Mars, have robots go there in advance and make the fuel for the return flight. And this is the kind of strategy that essentially SpaceX and Elon Musk is basing their strategy on. If you haven't heard of Elon Musk before, he's a billionaire entrepreneur from South Africa who invented the world's largest solar panel company, the world's largest electric car company, and the world's arguably most successful rocketry company. it was the first company that was able to launch a rocket and then land it again. So it's really quite groundbreaking. And people asked him, like, why are you pursuing these renewable technologies and landing rockets? What's your motive? And he said, well, I'd like to die on Mars, just not on impact. And he went on to say that the other like major goal that the SpaceX has is to grow a rose on the surface of Mars, something which is quite close to my heart. And he was saying like the motive for this is to kind of reignite the passion that once existed in America for space exploration. Like back in the Apollo era, people were really excited by space exploration. People had just landed on the moon, and people were discussing like the next trips to Alpha Centauri and beyond. It seemed like the impossible was possible, and there was no limit to what science, technology, and humanity could achieve. This was reflected in like the architecture and designs of the buildings and the cars of that era. You know, the old fenders on those old cars from back in the 80s. Like, it looks just like the space shuttle fenders. So, and so he believed that by getting people excited by spaceflight again, we could kickstart another kind of burst and kind of technology, which could hopefully make the Earth more sustainable. Hence his interest in like electronic cars and low carbon sort of technology. And so if we're going to go to Mars, it's a long journey. Depending on when you take off, it takes about like the minimum of like 9 months. And so you're going to be in a very small space, and so you really want to be able to take lots of food with you, but it would be great if some of that food can be regenerative. So a lot of people think that taking seeds and growing a certain part of their diet on the way there and on the way back will be really useful for them for nutritional content. Let's face it, everyone knows that eating seasonal and local food is really important for you, and that's true for astronauts. The microgravity environment of spaceflight, combined with the cosmic rays, is actually really hard on their body. That's why Scott Kelly was such a hero for spending that time in orbit with his twin brother on Earth, because that allows us to look at the physiological consequences, like how does the human body adapt to outer space. And one of the things that we've learned is that bones lose their density and muscles slightly deteriorate. And so the best way to combat these types of things is through a good diet. And so we would really like to get like dwarf plum trees growing in space so the astronauts can eat plums, because they actually do prevent those two, the muscle loss and the bone loss. That's something that my grandmother once told me. I'm also really interested in the potential for a moon base. Mars definitely is definitely the target of NASA, but the European Space Agency and the Chinese Space Agency and the Russian Space Agency have all identified the lunar base as being a more important and more short-term target. So recently I was fortunate enough to go to Beijing and to meet the Chinese Space Agency and have them talk about the creation of their space station and their plans for their moon base. So because the Chinese Space Agency were not allowed by Congress to collaborate with NASA and the other international communities on the International Space Station, they've gone ahead and created their own space station, the Chinese Space Station. It's still in its infancy, but looking at the design and like the timing of their program, I think it's going to be a very sophisticated tool that they create. It's going to be a really interesting laboratory up on orbit. It will also be fascinating to see how that competes with the private space stations that are also due for launch around that time. There's a company called Bigelow Industries. He's a billionaire entrepreneur who made a lot of money in Las Vegas as that expanded, and he thinks the next property bubble is going to be on orbit, and so he's designed these inflatable space stations. So it'll be interesting to see how like the public model, like the next public model, which will be the Chinese space station, and that private model, like the Bigelow Industries, and how those two different entities will coexist in low Earth orbit in the near future. But NASA have their sights set on Mars, and so the story isn't going to remain in low Earth orbit. We're going to be going beyond to cislunar space. The next stage on the NASA program is sending the Orion capsule to go around the moon. So this is going to be the first time that any tool created by our space agencies has gone below low Earth orbit since the Apollo era. So we're going back into what they call cislunar space, as what they call the proving ground. So if they're going to go to do a flyby on Mars, which is the next step before sending humans, they want to make sure they can get their capsule back from the moon. So we're going to be seeing that in the next couple of years before they go back, before NASA push on to Mars. The Chinese Space Agency, they plan to build their lunar palace on the moon in 10 to 20 years, again depending on the success with their space station. See, the interesting thing about rocket science is timelines are never built in stone because the funding is very political. With our current government, we don't believe that the space exploration program is going to receive too much of a cut because it's going to lead to the world's best reality TV show ever. And we all know how he likes reality TV. Whereas the Earth sciences will probably be hit hard because some people don't like looking at the North Pole from outer space because it paints a very clear picture. But when the Chinese Space Agency go back to the moon, you know NASA will be following very fast. If you look at if you hear Neil deGrasse Tyson talk about the space race back in the 80s and the 90s, he's very vocal about the role that the Cold War played in that and the mentality of the governments at that time. And so that's one of the reasons I'm intrigued to see what happens when the Chinese lunar palace is made and how we shall respond. Although, to be honest, I'm more excited by the European Space Agency's strategy for a moon base. They currently have designs for robots that they will send to the moon that will 3D print the habitat which the astronauts will eventually live in. Either way, it's really exciting. Like, space is coming back, and with the rockets taking off and landing, it's providing unparalleled access. Like, nowadays, when I speak to some of my students, I say to them, if you put your mind to it and you try hard, you can send your experiments up into microgravity. The company at the moment which is most exciting from an educational perspective is Blue Origins. So Blue Origins was a company that was created by Jeff Bezos, who was the founder of Amazon, and so they have created rockets that again take off and land. Last year their first rocket was able to take off and land I think 5 times, and has now been decommissioned and we put in a museum. And this year they're building at least 2 more. And their goal is to have multiple rockets taking off and landing from the space base down in Texas. And they want lots of people to be able to access space. It's this particular spaceship that launches off the top of their rocket has the biggest windows of any spaceship ever made, because they want people sitting up there looking down and seeing that curve of the Earth and seeing the darkness above and the beautiful blue seas below. They also really want students to be able to feed off this excitement and be able to test their curiosity and experimental capacity. And so they're making it really quite cheap for students to put experimental payloads on that particular rocketry system. So because of that, I got really excited by the local communities, trying to find the types of local kids that would be interested in trying to kind of work with these types of hardware. And that's when I stumbled across Madison West High School rocketry team. This team is phenomenal. Their trophy cabinet puts all other trophy cabinets I've ever seen to shame. These kids are brilliant. And so I got speaking to them by coincidence at an outreach event, and it was tremendous. They're able to build their own rockets, and they've actually fired a rocket and then fired a secondary rocket off the top of that. And I said to them, wow, I know the engineering required to do that is really, really phenomenal. But what was your scientific experiment? What were you testing? And they went, oh, we weren't testing anything, we just like firing rockets, we're like blowing stuff up. And I laughed and went, okay, I can relate, who doesn't? But you created a really cool tool there. It's a lot more than just a big firework. Like, perhaps we could work together and try and design some experiments to go in it. And so since then they've been developing payloads which allow them to take plants on those rockets. They then retrieve those plants and start to do experiments on them, trying to see how that rocket flight actually affects the plant's genetics and its subsequent growth. Because you can imagine, if we wanted to create a dwarf orchard on the moon or on the space station, then we'd have to launch these little trees. So what is the consequence of putting a plant in a rocket and taking off? And so that's literally what we've got these high school kids investigating. And as we do this, we have in the back of our mind the fact that once they develop the right skill sets and the right knowledge, there's nothing to stop these kids going to work for Blue Origins, these other like aerospace companies, in the long run. But in the short term, maybe even like designing like high school experiments to go on these new tools. And so yeah, we're trying to really take this opportunity and the excitement that we get from working with NASA and give that to like the local kids and trying to release their creativity and see what they can create. So finally, the future. So what's next? And that's our next space launch. So you try not to show fear, but when it comes to experiments in space, you get one shot. You don't get lots of attempts. If it goes wrong, it goes wrong. And I've met people that have had experiments loaded onto rockets that have then exploded, and there went their opportunity, and it was no fault of their own. But the only thing I can think would be worse than that is it going wrong and it being your fault. So that's also one of the reasons I'm practicing with the local high school kids, to get the techniques down, because the techniques I'm teaching them are literally the techniques we use when we work with NASA to send plants to the space station. So NASA know that this is a difficult these are difficult experiments to kind of design, and so they're really great. They're really helpful. They have a team of people at the Kennedy Space Center. They help you do like a dry run of your experiment. So over the last year, we've been fortunate enough to go down to the Kennedy Space Center and work with NASA on 2 occasions to do dry runs, like practice runs, of the experiment that we're going to launch in November. So we're currently slated to launch in November on SpaceX 13. Like if you were a rocket company, would you ever fire rocket number 13? I would do 10, 11, 12, 14. I know my luck is going to be on a Friday, right? I'm not a superstitious guy, you know. I'm a scientist, but I never would have made a rocket number 13. And so now, like, we're just kind of in this waiting period as we've done our practice runs, and we just kind of have to remain optimistic. And every couple of weeks, I re-practice the experiment. I set it up with another one of my students and try and explain to them exactly how we will do it. Everything without the actual rocket launch itself. So the final thing is to say, like, I'm nervous. I'm got to be honest. But when that moment comes, you have to try to be brave, like suck it up, and just try and do your bit. Finally, I'd also just like to show my appreciation for the research group. So thanks to the professor, Simon Gilroy, the gentleman I work with. He looks like a wizard. He looks like Gandalf. He's got silver hair that comes down here. He's a very exciting person to work with, and he's allowed me to get a lot of students working together, a lot of professors, and ensure that we sit in our ivory tower in isolation and focus on a very sort of narrow academic problem. That's a very traditional way for academia to work. And this particular gentleman works very differently. He allows me to network with students all across the campus and actually internationally too, and create teams of people to work together for kind of like a unified goal. And so it's been really helpful to be able to have that kind of support. So yeah, so this has been a lot of fun. I've really enjoyed having this opportunity to discuss the work that we're doing. We do have a lab social media account. We blog everything that we do on Twitter and on WordPress website. So if people wanted to find out more, wanted to get involved and work with us, you can search for us online. We're the Gilroy Lab in Madison, Wisconsin. We're an AstroBotany lab, and we work with plant scientists, we work with engineers, we work with media students, and it's been a lot of fun. And so if you want to do it for the fun, if you want to do it for the science, if you want to get involved, if you just want a casual chat, we're real open to interactions and communication and collaboration.